This lecture deals with another class of finite automation generating output, that is Mealy machine. So let us consider an example. So having two states in your model Q0, Q1. So if we consider a Moore machine, associated to each state there exists an output symbol. But in the case of Mealy machine, we have to associate output to each and every transition. For example, from Q0, if input is A, it will generate output 0. From Q0, if input is A, transition will go to Q1 generating output 1. So that is the main difference between Moore and Mealy machine. In the case of Moore machine, output is associated to state, and in the case of Mealy machine, output is associated to transition. So it will be represented like this. And again, if we analyze this model, each and every states are having unique A-B transition. So this is basically a deterministic model. Again, if we compare this with finite automata, there does not exist any final state, which indicates that this will never act as a string acceptor. If you consider finite automata, it acts as a string acceptor, but this will never act as a string acceptor, but this will generate output for an input string. So what happens if the input is A, B, B, A? If input is A, B, B, A, without consuming anything, it will enter into Q0, it will read this A. It will take this A transition generating output 0. Whenever this model takes a transition, it will generate the output associated with that transition and attach that to the output string. Now from Q0, it will next input encountered is B. It will take this B transition generating output 1 and that will be attached to the output string. Now from Q1, the input encountered is B. So it will take this transition generating output 1 and remain in the same state Q1. Now from Q1, input encountered is A. So it will take this transition generating output 0. So from this it is clear that if input string is of length 4, it will generate output of length 4. In general, in the case of Mealy machine, for input of length n, it will generate output of length n. That is another difference if you compare Moore and Mealy machine. Now we can move on to the mathematical definition. Mealy machine is formally defined as M equal to Q sigma delta delta lambda Q0, which is same as that of the 6-tuple representation of Moore machine, where Q is the non-empty finite set of states, sigma is the non-empty finite set of alphabets or input symbols, delta is the non-empty finite set of output symbols, then delta is the transition function, that maps from Q cross sigma to Q. As I said earlier, this is actually a deterministic model. So the transition function will satisfy the property of a deterministic finite automata, and lambda is the mapping function that actually maps output to transition, or maps transition and output. So it maps from Q cross sigma to delta, and Q0 is the initial state. You can call it as start state or initial state. So this is the formal representation, formal definition of Mealy machine. So if you compare formal definition of Mealy machine and Moore machine, the only difference lies in this mapping function. So in the case of Mealy machine, it maps from Q cross sigma to delta. Now we can move on to the different representations of Mealy machine. So you can diagrammatically represent Mealy machine using transition diagram. So this is the transition diagram. Next one is mathematical representation. So you can mathematically represent this Mealy machine as m equal to q sigma delta delta lambda q0, where q equal to set q0 q1. Then what about sigma? Sigma equal to, you are having the alphabets a and b. Sigma equal to set ab. Now what about delta? Delta is a set of output symbols. You are having 0 and 1 as output symbol. So 0, 1. Now we can define the transitions. What is delta q0a? Delta q0a, if you from q0, if you apply input a, it will remain in the same state q0. Now what about delta q0b? To q0, if you apply input b, it will go to q1. Now what about delta q1a? To q1, if you apply input a, it will go to q0. Now from q1, if you apply input b, it will remain in the same state q1. Now you can define lambda, that is mapping function. So what is lambda q0a? To state q0, if you apply input a, it will generate output 0. Now what about lambda q0b? To state q0, if you apply input b, it will generate output 1. Now what about lambda q1a? q1a. To state q1, if we apply input a, it will generate output 0. Now what about lambda q1b? To state q1, if we apply input b, it will generate output 1. So that is the reason for this mapping function to map from q cross sigma to delta. So if we consider the parameters will be member that belongs to q cross sigma, and the result, it actually moves to delta. So that is the reason for this function to have mapping from q cross sigma to delta, and you can state that q0 is the initial state. So this is the mathematical representation of a Mealy machine. Now we can move on to the next representation, that is tabular representation. You can call it as tabular representation, you can call it as transition table. So you can consider the so you are having set of states. Let the states be q0, q1. You have to designate q0 using incoming arrow because this is the start state. Now you are having input and output. So you are having sigma here. So sigma, you are having input symbols A and B. Here you are having the target state and output. So from Q0 for input A, it will remain in the same state Q0 generating output 0. From Q0 for input B, it will go to state Q1 generating output 1. Now from Q1 for input A, it will go to state Q0 generating output 0. From Q1 for input A, it will go to Q0 generating output 0. Now from Q1 for input B, it will remain in the same state Q1 generating output 1. So this is the equivalent transition table. So if you are asked to design a Mealy machine for a particular problem, then you can come up with the transition diagram, transition table, or the mathematical representation. And based on the function lambda, you can trace the output generated by Mealy machine for a particular input stream. For example, in this case, the input is ABB. The output generated will be lambda Q0 A. So you can write like this, lambda. So what is lambda Q0 A? From Q0 it will take A transition generating output 0 and remain in the same state Q0. Now from Q0 it will generate lambda Q0B. Lambda Q0B, that is 1. Now it goes to state Q1. From Q1 it will generate lambda Q1B, which is 1. So for input ABB, it will generate output 111. So in this way you can trace the output generated by Mealy machine for a particular input stream. That's it.